Welcome to the fifth problem-based tutorial. In our previous session, we calculated the power factor of a half-wave rectifier circuit. In this tutorial, we will calculate the power factor of a series RL circuit. Problem statement. Determine the power factor of a series RL circuit. Getting started. Let's begin. Launch Simulink by clicking the Simulink icon in the toolbar. Now open the model we created in our previous lecture. Close this window. In that model, we performed measurements of instantaneous power, average power, apparent power, and the power factor. In today's session, we will measure the power factor using two methods. 1. Using the power block, and 2. Using the Fourier analysis block. Important note. Please note that these two methods are valid only for linear circuits. We cannot use the power block or Fourier analysis block to measure the power factor in nonlinear circuits. For nonlinear circuits, such as those containing diodes or thyristors, we must use the method we discussed in the previous tutorial. This is because nonlinear circuits generate harmonic components of voltage and current. Both the power block and Fourier analysis block calculate the power factor based only on the fundamental frequency. They do not account for harmonic distortion, and therefore will not provide the correct true power factor in nonlinear systems. Save the model. Click the drop-down menu next to the Save icon and select Save As. Next, give a proper name to your model. Click Save. Modify the model. Remove the diode block and reconnect the circuit. Remove all the other blocks that we had connected for power calculation in our previous tutorial. Method 1. Using the power block. Now go to the Simulink library. From the Simscape library, add a power block into your model. Right-click on the model and select Add to the model. From the Math Operations section, select a math function block and add it to your model. Also, add an add block, a square root block, and a divide block into your model. From the Sinks section, add a display block into your model. Let's arrange the blocks. Connect the input I of the power block to the output of the current measurement block, and the input V of the power block to the output of the voltage measurement block. Double-click the power block. Set the frequency to 50 Hz. Click OK. Connect a math function block to each of the P and Q outputs of the power block. Double-click the math function block and select Square from the drop-down menu. Do the same for the other block. Up to this point, we have calculated the apparent power. Now we need to divide the active power by the apparent power, P over S. Connect the display block. Click Run to start the simulation. Method 2. Using Fourier analysis block. Let's calculate the power factor using Fourier analysis block. Go to the Simulink library and type Fourier in the search bar of the library browser. Press Enter and select the Fourier analysis block. Right-click and add it to your model. We will need 2 of these blocks. From the Sinks section, add 2 Terminator blocks to your model. From the Math Operations section, add a Subtract block and a Trigonometric Function block to your model. Also, add a Display block from the Sinks section. Now let's connect the components according to the formula. Connect the input of one of the Fourier analysis blocks to the output of the current measurement block. Connect the input of the other Fourier analysis block to the output of the voltage measurement block. Attach a terminator to the magnitude output of each Fourier analysis block, since we don't need it. Open the trigonometric function block and select cosine from the drop-down menu. Double-click the Fourier analysis block. Set the frequency to 50 Hz and set the harmonic number to 1. Do the same for the other Fourier analysis block and click OK. Now let's start the simulation. As you can see, we obtain the same power factor as we achieved in our previous method. Summary. In today's lecture, we measured the power factor of a linear circuit using power block and then Fourier analysis block. Your task: apply both methods to a half-wave diode rectifier circuit and compare the results with the result obtained in the previous example. Thank you for being with us.